In this video, we'll be talking more about graph transformations. In our previous videos, we've gone over shifts and scales. In this video, we'll be going over reflections, which is a type of scaling. Remember that when we multiply by a number, we scale our graph in some way. If that number is negative, then our graph will be reflected. Let's take a look with our example here. Unlike our previous videos, this time we're going to be working with the function f of x equals square root of x. We'll start by graphing this function, then we'll want to compare it with the graphs of y equals negative f of x and y equals f of negative x. Let's start by making a table of values for our original function. For our table here, let's look at the x values 0, 1, and 4. We picked these specific x values because the corresponding y values are nice whole numbers. To find the corresponding y values, we take these x values, we plug it into our function to find the output. So when x is equal to 0, the square root of 0 gives us 0. When x is equal to 1, the square root of 1 gives us 1. And then when x is 4, the square root of 4 gives us 2. Let's plot our points and draw the graph. We have 0, 0, 1, 1, and then 4, 2. Connecting these points, we get the following graph. This is the graph of the equation y equals square root of x. So now let's take a look at the equation y equals negative f of x. We consider this as a type of scaling because we're essentially multiplying our function by -1. So with our function f of x being square root of x, this is the equation y equals negative of square root of x. Let's make a table of values for this equation. And again, we'll use the x values 0, 1, and 4 because I know that the corresponding y values will be nice whole numbers. If we plug in 0, negative of square root of 0 is still 0. If we plug in x equals 1, negative of square root of 1 would be -1. And if we plug in x equals 4, negative of square root of 4 would be -2. If we compare this blue table with our original purple table, you'll notice that all of the y-coordinates have the opposite signs. Before, they were 0, 1, and 2. Now, because we're working with negative of our function, the y values are 0, -1, and -2. If we plot these points, we have 0, 0, 1, -1, and 4, -2. Connecting these points, we get the following graph. This is the graph of y equals negative of square root of x. When we compare our purple graph with our blue graph, we see that our graph is flipped across the x-axis. That's why this is called a vertical reflection. Any point that we had in our original graph, our y-coordinate is multiplied by -1, which flips it across the x-axis. Now let's look at the equation y equals f of negative x. To evaluate f of negative x, we take our original function and everywhere we have x, we replace it with the new input negative x. So our equation looks like y equals square root of negative x. This time, there is a -1 being multiplied in our input. So we expect that this transformation will affect our x values in some way. So let's make a table of values for this equation. Because we want to compare our function with the original purple function, and because we expect our x values to be affected, we're going to make our table with the same y values as the original function. So we'll put down 0, 1, and 2 in our table, and we'll try to find the x values that give me those corresponding y values. So for our first entry here, we want to figure out an x value that we can plug into the equation so that we get 0 as the corresponding y value. Notice that if we plug in x equals 0, multiplying it by -1 is still 0, then taking the square root, we end up with 0. So when we plug in x equals 0, we get y equals 0. Next, we want to figure out an x value that I can plug in to get 1 as the corresponding y value. This time, we need to plug in x equals -1, because if we plug in x equals -1, multiplying that by -1 turns into +1, That way, when I take the square root, it becomes positive 1. So when x is negative 1, the y value is positive 1. Lastly, we want to find the x value so that when we plug it into our equation, we get 2 as the y value. This time, the x value would have to be negative 4, because if we have negative 4 in for x, negative x would be positive 4, then taking the square root, that gives us positive 2. So when x is negative 4, the corresponding y value would be positive 2. Now, comparing this red table of values with the original purple table of values, we see that all of the x-coordinates have the opposite signs. In the original function, we have the x values 0, 1, and 4. In our transformed function, instead of the input x, we have the input negative x. And we see that the x values are now 0, negative 1, and negative 4. So now let's plot these points. We have 0, 0, negative 1, 1, and negative 4, 2. Connecting these points together, we get the following curve. This is the graph of y equals square root of negative x. When we compare our red graph to our original purple graph, we see that our graph is flipped across the y-axis. We call this a horizontal reflection. Any point that we had on our original purple graph, we would multiply the x-coordinate by negative 1, and that flips the point across the y-axis. So from our example here, we've learned that if we have negative of f of x, this is a vertical reflection, which means our graph is flipped across the x-axis. If we have f of negative x, this is a horizontal reflection, which means that our graph is flipped across the y-axis. So in this video, we learned that scaling by a negative number leads to reflections, which flips the graph either vertically or horizontally. In our next video, we'll learn how to modify functions to have the desired graph transformations.